Have you ever found yourself stuck trying to apply a function to a CUDA tensor in PyTorch, only to feel overwhelmed by the complexity? If that's you, you're in the right place. Today, we're diving into how to apply functions element-wise to a PyTorch CUDA tensor using parallel computation. I totally get it. Working with CUDA tensors can be tricky, especially when you want to apply a custom function efficiently. You're not alone in this struggle. Many developers face similar challenges when trying to optimize their code. Here's the specific question we're addressing today. A user asked, how can I apply a custom function to a PyTorch CUDA tensor in parallel? They want to know how to efficiently use their defined function with CUDA tensors. Sound familiar? Let's explore this together. So, what's the deal with applying functions to CUDA tensors? When you work with large data sets, applying functions in parallel can significantly speed up your computations. Understanding how to leverage PyTorch's capabilities will help you get the most out of your GPU. And stick around. At the end of this video, I'll share a powerful tip that can enhance your performance even further. To apply a custom function element-wise to a PyTorch CUDA tensor, the user should first ensure that their function is compatible with PyTorch operations. This means it should accept a tensor as input and return a tensor as output. Next, the user should create a CUDA tensor. This can be done by using the torch library to generate a tensor and then moving it to the GPU. Now, the user can apply the function f to the CUDA tensor. To do this efficiently, they should use the torch's built-in functionality to ensure that the operation is performed in parallel on the GPU. Finally, the user should verify the results. They can do this by checking the output tensor to ensure that the function was applied correctly. Fun fact, the first GPU was released in 1999 and was primarily used for rendering graphics. Now they are essential for deep learning and scientific computing. Now let's look at the answers provided by other users. This user suggests that currently, explicit parallelization of a function on a CUDA tensor isn't possible. Instead, they recommend defining a function similar to nonlinear activation functions and using it in a neural network. However, they caution that this approach may not work because it requires defining a CUDA function and recompiling PyTorch. Here's that powerful tip I promised. Always profile your code using tools like torch.utils.bottleneck to identify performance bottlenecks and optimize your function accordingly. And there you have it. You now know how to apply functions element-wise to a PyTorch CUDA tensor using parallel computation. Remember, optimizing your code can lead to significant performance improvements. If you found this video helpful, please subscribe for more tips and tricks.